Hi, thanks for joining me. Today I'm going to be evaluating the integral from 0 to 1 of inverse tan of sec x plus tan x dx. Let's get stuck in. To begin with, what we're going to do is start by taking the thing inside our inverse tan, so that's sec x plus tan x, and seeing what we can do with that. Now we're going to put cos x on the denominator here, and then what do we get on the top? Well, it's just 1 plus sine x. Okay, and the trick here is I'm going to replace the x's here with x over 2's using some double angle formulae. So this is just going to be 1 plus 2 sine of x over 2 cosine of x over 2, all divided by cos squared of x over 2 minus sine squared of x over 2. Cool. Now what I'm going to do is divide top and bottom by cos squared of x over 2. So my numerator, this 1, becomes a sec squared of x over 2. And then 2 sine x over 2 cos x over 2 just becomes 2 tan x over 2. And on the bottom, dividing by cos squared of x over 2, this cos squared just becomes 1. And then I've got minus sine squared divided by cos squared. And so that's just tan squared of x over 2. Lovely. Now I'm going to use the fact that sec squared is the same as 1 plus tan squared. So this thing here I can write as 1 plus, and replace that with tan. But now my numerator is a nice square number. It's tan of x over 2 plus 1 squared. And I'm dividing it by 1 minus tan squared of x over 2, but using the difference of two squares. This is 1 minus tan of x over 2 times 1 plus tan of x over 2, like so. So doing a nice cancellation with this and one of the guys on the top, I'm just left with 1 plus tan of x over 2 divided by 1 minus tan of x over 2. And now, why is this really nice? Well, what I'm going to do is put a pretend 1 here, and we notice that it looks a little bit like our double angle formula for tan, or sorry, our compound angle formula for tan. If we can think of a number such that tan of theta equals 1, and we can, theta would just be pi over 4. So this thing here turns out to be the exact same thing as tan of pi over 4 plus x over 2. So sec x plus tan x is actually the same thing as tan of pi over 4 plus x over 2 in disguise. And now it's kind of, we can kind of see how that's going to help us up here. But we've got to check, of course, when we do inverse tan and tan, before we cancel them out, we do just have to think about the value inside the brackets here. So before we just cancel the inverse tan and the tan, pi over 4 plus x over 2, well, x is between 0 and 1, so x over 2 is going to be between 0 and 0.5. Pi over 4, well, pi over 4 is definitely less than 1, and so if I add 0.5 to that, that's going to be less than 1.5, and thankfully 1.5 is less than pi over 2. And so therefore this guy here is definitely going to be between 0 and pi by 2, in fact between minus pi by 2 and pi by 2. And so in particular when we do inverse tan and tan, they are going to cancel, and I don't have to worry about adding a multiple of pi or subtracting a multiple of pi or anything like that. So this becomes very nice, just the integral from 0 to 1 of pi over 4 plus x over 2 dx. And now this is just straightforward. This is going to be pi over 4 times x plus x squared over 4. And then we just plug in 1 and 0. Quite clearly when we plug in 0, everything will disappear. So this is simply going to be pi over 4 plus 1 over 4, 1 over 4, sorry. And so that's going to be pi plus 1 over 4. And that there is the final answer. So the integral from 0 to 1 of inverse tan of sec x plus tan x dx is just pi plus 1 over 4, using this very nice trick of writing the sec x plus tan x as tan of pi over 4 plus x over 2. If you have enjoyed this video, please do give it a thumbs up, and if you are new to the channel, please do subscribe if you haven't already. Thank you so much for watching. I'll catch you in the next one. Have a great day.